Okay class, so we continue. In this video I will proceed with step 3. Okay, step 3 is a Fourier series solution. But before I proceed to the step 3, I will give you one example. Okay, this example is regarding the previous step. Okay, is solving the separated equation. Okay, so this is the example. Solve the PDE below using separation of variable method. Okay, so this is the equation given. Alright class, so if you get this type of question means that you need to start all over again with step 1 lah. Okay, don't simply go to step number 2 terus, jangan. You need to show this equation separable or not. Okay, that one the first step lah. So you need to do it that one first. So means that step number 1. So you have 4d square u dx square equal to du dy. So you need to replace d square u dx square with x double prime y equal to xy prime. And then we will divide by xy. So cancel. Okay, cancel this one. So therefore you left with 4x double prime over x equal to y prime over y. And then you see that x is on one side and y is on another side. So that means this is a separable. Okay, it's separable. Then we can go to step 2. Okay, step 2 is solving the separated equation. So you have two equations here, class. So they have two equations here. So the first equation is this one equal to k, and the second one is y equal to k. Alright, so the difference here between this example with the previous example, I just want to highlight about this scalar or these numbers lah ataupun coefficient here. So they have 4 in front of it. Okay, class. To make it your life easier on when you calculate, because it's not just it's not compulsory, but I really suggest you to move these 4 or any numbers that we have in front of x. Okay, any number that we have in front of x equation here, you move to this equation. Okay, so from here, okay, it's from this equation lagi lah. Okay, from here, so we have 4x double prime over x. So we want to move 4 to this side. So x double prime over x, move 4 to this side. So there will be 1 over 4, 1 prime over y. Okay, please, I really suggest you to move 1 over 4 to this side. So they have no 4 in front of x now. Okay, so you just have x double prime over x equal to k, and 1 over 4 y prime over y equal to k. Alright class, okay, then so this is step number 2. So means that you need to do it for each cases. So we start first with the case number 1. Case number 1 is when your k is positive, therefore your k is equal to lambda square. Right, so this is case number 1. So we do it for x prime x first, which is x equation first. So x double prime over x equal to lambda. So x double prime minus x lambda square equal to 0. Okay, so this is x double prime. This is x double prime. So means that will be m square. Okay, it will be m square. So m square equal to lambda square. So m equal to plus minus lambda. Okay, plus minus lambda. Therefore, what is your x equation here? It will be C1 E lambda x plus. Okay, they have plus lah because we have 2m here. Okay, C2e negative lambda x. Okay, alright. So this is the first equation of x. So now we do it for y. So the equation for y just now is y prime over y equal to k. So we do it the same thing. So y prime over y equal to lambda square. So you get So now class, this 4 over y, 4y is down here, right? So we will move 4y to this side. So it will be y double prime equal to 4y lambda square and equal to 4y double prime y prime, not y double prime, y prime. Okay, y prime minus 4y lambda square equal to 0. So replace with m, so m minus 4 lambda square. And your m is equal to 4 lambda square. Therefore, the equation for y is given by C3 e power of 4 lambda square y. Then the equation, also the solution for this case 1 is equal to, okay, you have C1e lambda x plus C2e negative lambda x, okay, times with C3e 4 lambda square y. Okay, and as I showed already in the previous video, when if you can see that you will multiply C1e lambda x times with C3e 4 lambda square y, is it? So C1 times C3 we will let as A1. Okay, C1 A1 is equal to C1 times C3. Okay, C1 times C3 you let as A1. So A1, so then you will have here E lambda x plus 4 lambda square y, okay, and then plus C2 times C3, so you will let A2 or B1 lah, okay, B1. A2 we will use for the next case, okay, B1, okay, B1, we use B1, okay, B1 as C2 times C3, so C2 times C3 you get B1 and then you have E negative lambda x plus 4 lambda square y. So this is the solution for the case number 1. Okay. Now we will do it case number 2. So case number 2 is when your k equal to 0. Okay, so we have x double prime over x equal to 0 now. So therefore, we have x double prime only equal to k equal to 0. So m square equal to 0. So m equal to plus minus 0. Okay, class. So this one, careful. Even though we know that plus minus 0, okay, plus 0 is also equal to 0 and negative 0 is also equal to 0, right? But you cannot consider as 1. You need to consider this is a two number. So this is a real and repeated class. So because many of before this I saw that many of you are not many, I mean just your senior do it that it's just considered as 1 because we know that plus 0 is 0, negative 0 also 0, but it's a two numbers. Okay, it's a two, means that it's a real and repeated. So therefore, your equation here is just now is C4, okay? Now is C4 what? C4 e power of 0x plus C5x e power of 0x. So they have x here. Okay, then you simplify lah. We know that e power of 0 is 1. So therefore, you are left with C4 plus C5x. Okay, C4 plus C5x. Okay, so this is your x equation. Okay, now we do it for y equation. Y prime over y equal to 0. Therefore, y prime equal to 0, m equal to 0. So this is only one m. So only one. So they have no real and repeated. It's just real because it's just 1. So the equation for y is given by C5. So C6 e power of 0x. Therefore, 0y. Therefore, there will be C6 only. So the final answer or the final solution for case number 2 is given by, so this is your x is now C4 plus C5x, okay, times with C6. So C4 times C6. So we use A2. Okay, so A2 is equal to C4 times C6 class. Then plus C5 times C6 we let as B2x. Okay, so B2 here is C5 times C6. Okay, So they have x lah, of course lah, so ini ada x kan, so they have x. Okay, so this is the solution for case number 2. Okay, next, case number 3 is when your k is negative, which is your k is negative lambda square. So you have x double prime over x equal to negative lambda square now. So negative lambda square. So x double prime plus x lambda square equal to 0. So m square plus lambda square equal to 0. M square equal to negative lambda square. So m equal to plus minus square root negative lambda square. No. I mean they have a square root negative inside there, so there will be plus minus lambda I. Okay, class, plus minus lambda I. So this is a complex conjugate lah. Okay. So complex conjugate here. So therefore the equation that you get for x here is given by E A x. Right? So what is your A? Your A here is 0, so 0x. So I just write down first. Okay. If you can, congak, you can write your answer directly. But I just want to show for those yang maybe lupa. So here in front here is A. So your A here is 0. And then you have A cos x plus B, right? So but now we don't want to use A and B and so on. We need to use C. Just now the last one here is C7. So now C6. So now is C7. C7 cos lambda. Okay, your B here is lambda. Okay, class, you need to compare with A plus minus BI, right? So A here is 0 and your B here is lambda. So lambda lambda x plus C8 sine lambda x. So you simplify, okay, e power 0 is 1. So they have C7 cos lambda x plus C8 sine lambda x. Okay, right, so this is the x equation. So now we proceed with y equation. So y prime plus y 0, so m plus square. So m equal to negative lambda square. So this is a real, it's not a complex conjugate or so whatever. It's just a real. So just substitute into this equation. So C8. So now C9 e power of negative lambda square y. Okay. So the final answer for this one will be uxy equal to xx yy. So therefore your x here is C7 cos lambda x plus C8 sine lambda x, okay, times with C9 e negative lambda square y. Okay, so you did the same thing, C7 times C9. So just now we stopped at B as A2, right? So now this one will be A3. Okay, A3 is equal to C7 times C9. So A3 cos lambda square e power of negative lambda square y. So you still need to take all of this. Okay, you need to bring. What we change is only for C7 times C9, we just let as A3. Okay, that's all. Yang lain tu you kena bawa juga. Kena. Jangan tinggal. So cos lambda x times with e negative lambda square y. And then plus C8 times C9, so I let as B3. Okay, B3 is when C8 times C9. So you still have sine lambda x and e negative lambda square y. So this is the solution for case number 3. Okay, class. So this is how we solve for PDE if we get this type of question, class. Okay, tengok soalan ni just give you this equation, and then what we did just now is you need to do each cases, you need to solve each cases, and then for each cases your final answer is still exists an unknown. Unknown here means that A1 B1. Okay, I mean you punya jawapan akhir still dalam bentuk unknown, still ada unknown, still ada A1 B1, and then what else, C1 A2 B2 and A3 B3. They have still unknown. Okay, so why I mentioned this one, because okay, when we go to step 3 is Fourier series solution. for step 3, it's similar like step number 2. Okay, it's similar, but the step 3 is more complex or more steps that we will apply because of we need to find this value A1, A1, B1, A2, B2, B3 and so on. Okay, in step number 3. Step number 3 is Fourier series solution, whereas we need to find all the coefficient or all the scalar. So if you get this type of question, okay, I mention again here, if you get this type of question, it's just simple, right? It just give you an equation and so on. So this one, how we want to cater or how we want to answer this, like what I showed just now, means that case 1 you do it x, y, and then you leave the final answer is in term A1 and B1. But class, so if you get this type of question, okay, I give you, okay, I write down the question. Okay, let's say you have this type of equation, du dt 4d square u dx square, and then it gives you another extra information, which is BC here, u0 t0, and then d and so on lah. Okay, I mean this type of question, it will give you an extra information. For example, here you can see that they have a BCs. Okay, class BC is stand for boundary condition. Okay, BC is stand for boundary condition. And if you get another one, we have IC. So IC is initial condition. So if you get this type of question, whereas you have an equation, you have a BC, you have an IC, so you know that this one you need to answer by using step number 3. Okay, so even though it's step number 3, yes, you still need to start with step 1 lah. Of course lah, you need to show that one separable or not, but you don't need to show step 2. We jump to step number 3. Okay, so you can see the difference between this example and this example. This example is straightforward. It's just a simple equation without any extra information. But for this case, or for this example, they have a BC, they have an IC, and so on. So for this one, you just do it for step 2, and for this one, we do it for step 3. So when we do it for step 3, you don't need to do it step 2 already, because step 2 and step 3 actually is similar, but they have a different when we apply the Fourier series lah for step number 3. So I just give you an roughly idea about it. Okay, later in the next video, I will show you the example on step 3, how to use or how to solve by using the Fourier series solution. Okay, class? Alright.